Hello everyone, welcome to day number 4, Thursday. So today is review day, test tomorrow. So what I'm going to do is go over some notes. So y'all get out your graphing calculator and also get out your notebook so you can write this in. So you'll have the notes in front of you when you take your test tomorrow. All right, it's going to be broken up into 4 sections. I have not made the test out yet, so but I do know these are the 4 sections in it. So I don't know what the order is, but you'll see as you're going through the test which one to match this up with. All right, one of the 4 sections, section 1, we'll say right now, is going to be a yes or no question, and all you have to do is state: is the graph periodic? So if y'all remember, periodic means when you have the sine and cosine waves together, it forms another wave. So that would be a yes. However, if our wave does something erratic, okay, something weird or whatever, or it's a parabola, or it's a straight line, then our answer is no. These are not periodic graphs. All right, so what I'm going to do is I'm going to give you a couple examples to try. What I like for you to do is put this in your calculator, or pause the video, put it in your calculator, and then come back to the video to see if you are correct or not. All right, so here's your first one. The function of x is equal to x squared minus 2 cosine x. All right, pause this video, put this in your calculator, and then come back. All right, this is what you should have had. So I'm going to go y equals 2. I'm going to put in x squared minus 2 cosine x, graph. Now, if you look here, this looks like a parabola. Okay, so apparently I got my window all messed up, but it's a parabola. This is not periodic. So our answer would be no for this picture. Now let's look at this second one. F of x is equal to 2 cosine x minus 4 raised to the second power. Pause the video, put this in, see what you get. All right, let's put this in our graphing calculator. Since we have a parentheses right here, what I'm going to do is I'm going to open up the parentheses, put in 2 cosine, but look, it's got another parentheses there, so that means we're going to have to close it up, minus 4, and then we're going to put another set of parentheses, squared, graph. We can't see it very well, so I'm going to zoom out just to make sure. And as you can tell, this is periodic. And since it's periodic, therefore, you would say yes as your answer. All right, so that's how you do part 1, or one of these. That's the yes and no. Okay, so part 2, or a second part of the test, is where we did the composite functions. All right, so what we want to do is, not just composite functions, but we want to find the upper and lower bounds. Now, I did not make this statement on Tuesday, but I did look back in the book, and what is happening is the graph is oscillating. All right, so I said, you know, it kind of went up vertically, diagonally. Well, it's oscillating. And what does an oscillating fan do? It turns, right? So that's what's happening. Our graph is turning. So it's oscillating. So what we want to do is find out the 2 upper and lower bounds of the oscillating graph. All right, so find upper and lower equations. Okay, I can't remember how it's stated, but you'll recognize it when you see it on the test tomorrow. So let's say we have the equation y equals to 2x plus cosine x. All right, if you think you remember how to do this, pause the video and go ahead and try this. All right, so remember, the first thing you want to do is we need to figure out what the amplitude is of the sine or cosine. Well, the amplitude is the number, of course, in front. So in front of cosine, we have no number, so that's understood to be 1. So what this is going to be changed to 1. Now, we are going to have 2x plus 1, so that's like an upper bound. And then remember, since our cosine wave has the same amplitude going all the way across, you have to go down 1. So if we go up 1, you go down 1. So this is going to be 2x minus 1. So our two equations are y equals 2x plus 1 and y equals to 2x minus 1. All right, that's an easier one, so let's look at a more difficult one. Everybody try this one. Y is equal to 1 minus 0.5x plus 3 cosine 2x. Pause the video, try that one. All right, so our amplitude in this case is 3. So this is going to be 1 minus 0.5x plus 3 and 1 minus 0.5x minus 3. Since we have two numbers that we can combine, 1 and 3 is 4. So 4 minus 0.5x, I'm already thinking about y. And then over here, 1 minus 3 would be y equals to negative 2 minus 0.5x. And that would create your lower and upper bounds of your composite equation or function. And that's how you do part 2. Okay, I guess part 3 is going to be the most lengthy part of your test, this part. And this is where I give you the composite function, and I need you to find A, B, and H. Now, I don't want you to worry about being totally exact, because this is multiple choice. So make sure you just select the answer that's closest to what you get. All right, here is, of course, the function that we use. F of x is equal to A sine B x minus h. So that's what's really going on. Sometimes they have it where they want you to write the new equation with the decimals in it. I just want you to find A, B, and H. You can do that, and because we all can take these and plug it in to form the new equation, but you're not going to have to on this part. All right, so let's look at an example. The function of x is equal to 2 cosine x plus sine x. Pause the video, try this, and see what you get for A, B, and H. Okay, here we go. So in this case, we always look at the number in front of x with the sign to tell us what the B is. So we're using sine b in front of x. Here's sine, there's x, there is no number, so 1 would be b. Now we take our equation and we're going to graph it. I have 2 cosine x plus sine x. Graph. Of course, I am way out, so let's get a little bit closer. I think I can do a little bit better. All right, so let's go ahead and take care of A first. A is our amplitude. So we want what is the highest peak it is going in the Y direction. So you press the trace button, and we're going to try to get up here as close to the top as we can. So I'm going to look at my Y. See, it's going back down. 220, 21, 23, 20. That's 23.0, 23.5. So it looks like 2.23 or 2.235 or 2.24. So anything in that area. Okay, and that would be your amplitude. Now for your H. All right, what we're going to do is we're going to look at the phase shift, and we're going to see which one of these is closest to 0, 0, the origin. It's very obvious that this is closer than that side. So I'm just going to bring my cursor down over to the left, and now I'm going to look at my X. My X says negative 1.11 or 12 if you round it. So around negative 1.12. And that's how you find your shift to the left or right. Okay, let's try another one. Function of x is equal to cosine 2 pi x plus 3 sine 2 pi x. Find A, B, and H. Okay, pause and try it. All right, let's see what we have here. So what we want to do is we need to go to the sign, and we got to look at the number in front of x. The number in front of x is 2 pi. So B is 2 pi. Now, let's put this in our calculator and see what kind of graph we get. Cosine 2 pi x, close your parentheses, plus 3 sine 2 pi x. Graph. All right, looks like I'm going to have to do a little bit of zooming in order to get this point right here. So let's zoom in. Trace. All right, look, this is not getting me exactly where I need to go on there. So you're going to have to be really careful and make sure Well, I guess if I press trace again, it might let me move it up a little bit. No. Okay, so you're going to have to get, you just have to be careful, and you just have to get the number that's closest to what you get here. So in this case, we're on the negative side, and that would be around negative 0.05. All right, let's do the amplitude next. I know we could have done the amplitude first, but this one I'm going to have to zoom out. Oh, I might have to zoom out again just so I can get up there on the top. Zoom out. We'll eventually get there, won't we? Now, it really doesn't matter which one of these points that we hit because they're all supposed to be the same height. So when I hit trace, I just want to try to get as high up as it goes. And so if you look, there's a 3.12 it's going. That one's 3.06, so about 3.12, could be higher, but you can tell it's somewhere right in there. So 3.12 approximately is your amplitude. So that's how you do this section of the test. Now, your last section, section 4, I don't even have to show you any notes on it because it's basically what you're doing right here. You are going to graph. So that's what you've been doing the whole time anyway. So you're going to graph and you'll put in the composite function, and then I want you to pick from A, B, C, or D your choices of which composite graph matches correctly with your calculator with the test. And there you have it. So there's your notes, everyone. I hope all of you have a good day today, and be ready for your test tomorrow. See ya. Bye.